Have you ever stopped and wondered how computers actually see the world? It's not with words or pictures, it's all in numbers. But they're not always the numbers we're used to. Today, we're going to decode one of their most common languages and learn how to speak hexadecimal. So let's start with a little puzzle. On the left, we've got a number you see every day, 450. Pretty normal, right? On the right, you've got this string of letters and numbers a computer might use, C1C. Now, they look totally different, but I'm telling you, they represent the exact same value. So how on earth is that possible? I know what you're thinking. This must involve some super complex secret code. But nope, the key to unlocking this whole thing is just one simple rule. It all comes down to a single number. And that's our magic number, 16. The entire system, the whole translation, everything, it all hinges on this one number. You see, hexadecimal is what's called a base 16 system, and once you get that, everything else just clicks into place. So what do we actually do with this magic number? You won't believe how easy this is. You just take the number you want to translate, you divide it by 16 over and over again, and you pay super close attention to the leftovers, the remainders. That's literally it. Let's see it in action. All right, let's go back to our original puzzle. Converting the number 450, we're going to go step by step and see exactly how it transforms into 1C2. First up, we take 450 and divide it by 16. That gives us 28, but with a little bit left over. That leftover part, our remainder, is 2. Now you want to hang on to that remainder. It's the first piece of our answer. Next, we just do the exact same thing again. We take the result from that last step, the 28, and we divide that by 16. This time it gives us 1 with a new remainder of 12. Let's just set that aside with our first remainder. And we do it one last time. We take the result from before, which was 1, and divide it by 16. Now 16 doesn't go into 1, right? So our result is 0. And when you hit 0, that's your signal that you're done. The remainder here is simply 1. Okay, so we have our 3 remainders, 2, 12, and 1. But this brings up a problem. In a system where you need single digits, how do you write the number 12? You can't. And this is where hexadecimal has a really clever solution. Meet the hexadecimal decoder ring. Because we can get remainders from 10 all the way up to 15, hexadecimal just assigns a letter to each one. So 10 becomes A, 11 becomes B, and as you can see, our little problem number 12 becomes C. So if we use our new decoder, we can update our list of remainders. We had a 2 from the first step, our 12 now becomes a C, and we had a 1 from the last step. So our pieces are 2, C, and 1. We're so close. And now for the final, crucial twist. You don't read the remainders in the order you found them. You have to reverse it. You read them from the bottom up. So we start with our last remainder, which was 1, then the one before that, C, and finally the very first one we found, 2. And there it is, our solution. We put those pieces together in that order, 1, C, 2, and all of a sudden, our number 450 has become 1C2 in hexadecimal. It's not magic, it's just a new way of counting. All right, now that you know the secret, let's build up some confidence. We're going to run through 2 more examples, a little bit faster this time, just to really lock in the pattern. So take the number 865. If we apply the exact same process, dividing by 16 and collecting the remainders, we'd get 1, 6, and 3. We read those backwards, and 865 becomes 361. The pattern holds perfectly. Let's try one more with a letter in it, 680. After a few divisions, you'd end up with the remainders 8, 10, and 2. We know from our decoder that 10 is A. Reading them backwards, we get 2A8. See? The system is consistent every single time. Okay, so this is a neat party trick, but why does it actually matter? Because this secret language is everywhere. Ever see a color on a website with that little pound sign and 6 characters, like hashtag FF000 for bright red? That's hexadecimal. It's how computers precisely define every single color you see on your screen. It's also used to pinpoint exact locations in a computer's memory, which is totally fundamental to how software runs. So let's just recap your newer hexadecimal toolkit. You take any number, you divide by 16 until you can't anymore, and you just keep the remainders. You swap any number from 10 to 15 for its letter equivalent. Then you just read your list of remainders backwards, from bottom to top. That is the whole game. You've just learned to translate a new language. Not a spoken one, but a digital one.
It's a pretty cool reminder that even the most complex-looking systems usually hide a very simple key. It kind of makes you wonder, what else is out there, just waiting to be decoded?